Hello and welcome to a run through of the Open Awards Functional Skills Level 2 Maths mock paper.
Okay, question 1. The table below shows the distances walked by J each day in a week. And the question's asking us what is the total distance J walks over the course of the whole week. So this simply wants us to find the sum total of the values given in the table to find the total distance he walked. So we can either add these up as fractions, as they're given in the question, or we can convert them to decimals and add them that way. Either's absolutely fine, it's whichever you find most straightforward. So sticking with fractions for now, I'm going to make the calculation a little easier by adding some of the days together. So I'm going to pick Monday and Wednesday first. So it's 1.5 miles plus a half miles, so that's just 2. Then I'm going to pick Tuesday and Saturday. So that's 3/4 of a mile plus 3/4 of a mile. So that's simply 1.5 miles, or we can write this as 3/2. Then finally, we've got Thursday and Friday. So if you're converting these to decimals, be careful because they are non-terminating decimals, so that means they just go on forever. So it's 3.3333 recurring, and so on. But adding these together as fractions, we can write these as 2/3. Now, focusing on the first part, we have to add 2 plus 1.5. We can do that straightforwardly as decimals, or we can do it fully by converting it into a fraction with the same denominator as 3/2. So we've kept it exactly the same, we've just multiplied top and bottom by 2. So the ratio between the numerator and the denominator is the same, and we haven't changed the value of the fraction. So we've got 4/2 plus 3/2 now. Then we've still got that 2/3 to add at the end. So we simply add 4 plus 3 now, so that equals 7/2 plus 2/3. So now we've got two fractions again. We just need to add them together by first making the denominator the same. So to do this, we'll multiply 7/2 times 3/3. So this is still equivalent fraction to 1, so we're not changing the value in any way. So plus 2/3, and this time I'm going to multiply it by 2/2. So in each instance we're trying to get the value on the bottom to be 6. So 7 times 3, 21/2 times 3, which is 6. Then plus 2/3 times 2/2, so 2 times 2 is 4. And 3 times 2 is 6. Adding the values on the top together, we get 25/6. So we can rewrite this as a mixed number fraction by taking a value out. So that 25/6 is equivalent to 4/6 mile, and we can equally write that as a decimal, 4.1666 recurring, or rounded to 2 decimal places, 4.17 miles, remembering to add the units at the end. So question 2 now. Put these fractions in order of size, starting from the smallest and going up to the largest. So again, we could either work in fractions or decimals, whichever you find easier. So I'm going to stick with fractions again. In this case, we're going to make all the fractions have the same denominator, then just directly compare the numerator values and order them that way. So making them all into the same denominator first, 4/3. We're going to try and make the denominator in this case over 24. So here we have to multiply by 8/8. That gives us a value of 32/24. For the next term, 3/4. In this instance, we're going to multiply top and bottom by 6/6. So 6/6 is equivalent to 1. We're not changing the actual value of the fraction, we're just changing the numerator and denominator values, but keeping the ratio of the two the same. So 3 times 6 is 18, it's over 24. 3/8 this time, times 3/3. We get 9/24, 7/6 times 4/4, that comes out to 28 over 24. And finally 5 over 8 times 3 over 3, that comes out as 15 over 24. So now we've got each of the fractions given in the question, but with the equivalent denominator. So we can just directly compare the value on the top in each instance and order them from highest to lowest. So it's easy to see that this is the smallest fraction, so we'll label that 1 and go 2, 3, 4, 5. So that's our order from smallest to largest, but in the question we have to remember to rewrite them in the form that they're given, so making sure that we are careful to write the corresponding value for each one. So 9 over 24 is this fraction here, 3 over 8, so that's the smallest one. So write 3 over 8. Then for the second one is this one, so 5 over 8 is the next value up. 3 over 4. Then 7 over 6. And finally 4 over 3 is the largest value. So here we've written them in order from smallest down this side to largest up here. Moving on to question 3, it is asking us to calculate 273,696 divided by 24. So for this we're going to have to use long division. So we'll set up it like so, writing 696. So in this case it's sometimes handy when to just jot down the times table of the term you're dividing by. So in this case we'll do the 24 times table, just the first few terms. So 24 times 1, 24 times 2, 48 times 3, that's 72, and times 4 equal 96. We'll come back to this later on, it's just sometimes handy to have written down. So calculating the division, so here we're going to have to see how many times 24 goes into each of these terms, going from left to right. So first of all, how many times does 24 go into 2? Well, that's 0, so we write 0 up here. Bring down the 2 and bring down each of the following terms in order. So there we go. So it doesn't go into 2 at all, but we've carried the 2 down. So now we have to see how many times 24 goes into 27. Well, that's 1. And the difference between 27 and 24 is 3. So we'll bring the remainder down, and as before, just bring each of these terms down individually. You can separate them by lines to make the calculations a bit more clear. So now we see how many times 24 goes into 33. This is again 1, but the difference between 33 and 24 is 9, so we have to bring the 9 down, then again each of the terms. So this is where the table comes in handy, just to make it quicker to see how many times 24 goes into 96, which is exactly 4. So we write 4 up here, carry a 0 down, as there's no remainder, but it's helpful to remember that. 0, 9 and 6. So the next term we're looking how many times 24 goes into 0, 9, or 9 just if we ignore the leading 0. And that's obviously 0. So again, we'll carry the 9 down, 96. So how many times does 24 go into 96? Well, that's 4 times. So we add the 4 here. So we found the exact value of how many times 24 goes in 273,696, and that is 11404. We can just ignore the leading 0 here, and that's our final answer. Moving on to question 4 now. It asks us to calculate the surface area of a cube when the length of the sides of A is 15 centimetres. They also give you the formula for the surface area of a cube. With questions like this, it's often helpful to have a little sketch or drawing. So just have a really rough drawing. Cube doesn't have to be that accurate or any good. So here we have a cube, each of the side length is A, as in a cube all side lengths are equal. And in this instance A is 15 centimetres. So we want to work out the total surface area. So to begin with, we'll just work out the surface area of one of the faces. So we'll just pick the front face here. Got A. So the area of this square face of the cube is just A times A, or A squared. Now, since cubes have 6 faces, to find the total surface area, we just multiply the area of one of the faces by 6. So this is where this formula comes from, and they've given it just as a helpful reminder. So what we simply could have done is just plug in 15 into this formula and get the correct answer, but this is just having a quick run through of where that comes from. So we have total surface area is equal to 6 times 15 squared, and that comes out to 6 times 225, which is equal to 1,350. And remembering the units, which in this case is centimetres, and since it's an area, it's going to be squared. So that's the total surface area is 1,350 centimetres squared. So question 5 now. We're taught that Simon is redesigning his garden. He has drawn his garden on the scale diagram below, where we're told 1 square is equivalent to 1,500 millimetres. And we're asked, using the grid, to calculate the actual length of the garden in metres. So here we're given information in millimetres, but the question asks us to give our answer in metres. So the first thing we're going to want to do is convert this into metres. So 1,500 millimetres, simply 1.5 metres. So all we're interested in the scale drawing is the length. So all we have to do is simply add up the number of squares and use this conversion factor to calculate the actual length of the real garden. So here we've got 1, 2, 3, 4, 5, 6, 7 and a half. So we've got 7.5 squares. Each of these squares represents 1.5 metres. So we do 7.5 times 1.5, and that comes out as 11.25 metres. So there we found the length of the actual garden using the scale factor that they give and just simply counting the squares. Question 6 is now a continuation from the previous question 5. We're told Simon is planning to build a patio in his garden, and the patio will have 4 sides. He's drawn a quick sketch of the patio design below, which is a trapezium, and we're asked to calculate the area of the patio. So we should remember that the area of a trapezium is given by the formula half a plus b h, where h is the perpendicular height and a and b are the 2 other sides. So we can draw that quickly here. So that's the height is h. We're going to call this one a and this one b. So rewriting that here, so we have 6.6 plus 8.4 multiplied by the perpendicular height, which is 4. So now just plugging that in, so we can quickly simplify this by doing a half times 4, so it's 2, then 6.6, I messed up the decimal point there, is simply 2 times 15, which is equal to 30 metres squared. Always remember to put the units in at the end. On to the final question of the first section. We are told the foundation for the patio that Simon is building will use a dry mixture of sand and cement. He will need 20 kilograms of the mixture for each square metre of the patio. So immediately we need to remember from the previous part that the area of the patio is 30 metres squared. To make the mixture, he needs to mix sand and cement in the ratio of 5:1, where 5 parts of sand to every 1 part of cement, and we're asked to calculate how many 25 kilogram bags of cement he will need. So to do this, we're going to work out how much of the mixture he'll need to cover the entire patio area. So to do this, we're going to use the information given that you will need 20 kilograms of mixture for each square metre of patio. So what we need to do is just multiply 20 kilograms by 30 metres squared. That comes out as 600 kilograms of the mixture that he'll need. And we're also given that the mixture needs to be in the ratio of 5 to 1, with 5 parts sand and 1 part being cement. So what we're going to do is add the 2 parts together. So what we're doing is adding 5 plus 1, so you get it's being 6 parts in total. So 600 kilograms divided by 6 parts means that 100 kilograms is 1 part of this ratio, which is all we need to find, because we're just asked to find for cement, and we're told that cement comes in bags that are each 25 kilograms. So the final step of the question is us doing 100 divided by 4 is equal to 25. So we've worked out that he'll need 4 bags of cement.
Now in this video we're going to run through section B this time. This is the calculator part of the exam. So as you'll see on the right hand side here, there is a calculator that appears on screen for you to type in any of your workings throughout the exam. Now it will also record your workings in here, so if you don't quite get the correct answer, you can pick up method marks and working marks that will be stored here. If you've chosen to use a calculator that you've got in person, it has to be non-scientific, and there is also the chance if you don't get the correct answer, your workings won't be stored up here, so you may lose some of the marks that you would have picked up if you'd used the on-screen calculator, so that's just worth bearing in mind.
So moving on to question 8 now, the first question of section 2. We're told that Khalid wants to buy a 2-bedroom house no further than 0.6 miles from the station. We're also told that he's saved a deposit of £4,875 and the mortgage he can get is 3.5 times his annual salary. We're given a scatter graph with some information about the house prices and corresponding distance from the train station for recent sales of 2-bedroom houses. What the question's asking us to determine is whether Khalid can afford to buy a 2-bedroom house within the desired 0.6 miles of the station. We're also given a conversion factor between miles and kilometres, so that should be a hint that we're going to have to do a unit conversion at some point in this question. And given a quick scan of the scatter graph, we can see that the distances given as the x values are given with units of kilometres. So what we're going to want to do first of all is convert this 0.6 miles into kilometres, and we simply do that by multiplying it by 1.6. That comes out to be 0.96 kilometres. So what we're looking at reading off the graph is a data value that corresponds just to a bit less than 1, which is roughly there. And if you wanted to give a quick line of best fit sketch, it'll look something like that. Reading off from the graph, it'll correspond roughly to a house price of 105k. So that's the likely cost of a house within 0.6 miles or 0.96 kilometres. So what we're going to have to do now is work out whether that's affordable. So we're given the information that the mortgage he can get is 3.5 times his annual salary of 28,145. So calculating that value, we just multiply it and putting this into a calculator, it should be a comma, and that comes out as 98,507.50. We always add the 0 at the end for money. That's 5. But that's the mortgage he can get, but we're also told that he's saved up for a deposit, so we have to add that value to the total. So if we add that to the mortgage value, it comes out to a total of 103,382.50. which is less than the most likely value for house prices within this desired range of the station. So we can say that it's unlikely that Clede would be able to afford a house within 0.6 miles of the station. Moving on to question 9, we are asked to find the mode of the following set of numbers. So mode is the most often number that appears in a data set, so what we have to do is identify the number that appears the most in the listed numbers given. And scanning through, we can see that 8 appears twice, 7 appears twice, 8.5 only appears once, 23 once, 9 only once, and 7.5 only once, and we're left with looking at 11, which appears 3 times. So the modal value is the most common value in the set of data or set of values given, which in this instance is simply 11. Sticking with the same topic, the next question asks us to calculate the median of the following set of numbers. So median is the middle value. So what we're going to have to do first is write the numbers given in order from largest to smallest. So starting off, we have 9 and 9.5 are the first 2 values. We'll cross them off as we go through them just to make sure we don't miss any out or double count any. Then next 2 values are 10 and 10.5. Cross these out. Then we have 11, 12, then finally 15 and 23. So we get given 8 different values. So the middle value, if we count in from the left hand side and the right hand side, will be directly in the middle. We can either show this by counting or just know that since there's 8 values, it'll be in between the 4th and the 5th value. So just highlighting that, we just label them 1, 2, 3, 4, and 1, 2, 3, 4. So it'll be somewhere in here that the median value will be. Since we know we also know that it will be halfway in between those 2 values. So to find out the value of the mean, we simply add these 2 up, which is 10.5 plus 11, and divide by 2. And this will give a value of 10.75, which is the median value for the set of numbers given. Next, we get told that Amy wants to catch the 12 minutes past 10 train from Darlington to Chesterfield. She needs to allow 10 minutes to buy a ticket and get to the platform once she's arrived at the station. And we're also told that she lives 2 miles from the station, and we're assuming that she walks at a constant speed of 3 miles per hour. The question's asking at what time should she leave home. So for these sorts of questions, it's often a good idea to sketch a timeline. So we're going to say she starts off at the house, walks to the station, then has to get to the platform before boarding the train at 10:12. So we can write the times on and work backwards. So we know she has to be at the platform no later than 12 minutes past 10 to catch the train. So that's what we write there. So then we also know that it'll take she needs to allow at least 10 minutes for her to buy a ticket and get across the station to the correct platform. So working backwards, we know she has to arrive at the station by 2 minutes past 10. That's simply subtracting 10 from this time here. So we're told that she lives 2 miles away, and we're assuming she walks at a constant speed of 3 miles per hour. So to work out how long that will take, we use the relationship between speed, distance and time, which you can either write like that, or if a triangle method's more helpful for you, right, some people find it easier, speed and time. So rearranging this to find the time it takes, we bring time up here and speed down here. So we have time is equal to distance over speed, which from the information that we're given in the question, we know is 2 miles and 3 miles per hour. So this is 2/3, and that's 2/3 of an hour that it'll take her to walk. So to work out that time frame, we have to multiply it by 60, as the 60 minutes in an hour. So that comes as 40 minutes. So it'll take her 40 minutes when she leaves her house to walk to the station. So to find the time that she needs to leave in order to be able to board the train at exactly 10 minutes past 12 is simply taking 40 minutes off this time here, which will work out as 9:22 AM, which is our final answer. Moving on to question 12 now. We're told that Tom is given £8,500 to go towards a deposit to buy his first house. And Tom is looking into two different savers accounts. The money saver account, we'll label that as 1, and the bonus saver account, we'll label that as 2. Tom decides to put his money into the money saver account, the first one here, and what the question's asking is how much more money will Tom receive after 3 years compared to the bonus saver account. So just looking at the terms quickly of each one, we get told that this will pay 1.75% interest per year to be added at the end of each year. So this will be compound interest, where the interest is added on the amount at the end of the total amount in the account at the end of each year. Looking at the second one, the bonus saver account, we're told that you save for 3 years and receive a single lump sum bonus of a higher interest rate at 5.25%, but that will just be on the original value that Tom puts in. So that's just simple interest. So calculating the amount each will return for the money saver account first. We get told it's £8,500 he puts in to begin with, and we're going to use the decimal equivalent of the percentage here, which is 1.0175. Now this calculation would give us the value in the account at the end of the first year. We can then multiply that again by the same percentage decimal equivalent, and then again for a third time. Equivalently, we can write that as 1.0175 cubed, which is exactly the same as writing out 5 times 1.0175 times 1.0175 times 1.0175. These two are exactly the same calculations. This is just written in a more shorthand way. So plugging either one of these into the calculator will get you a value of 8,954 and 10 pence. So that'll be the value after 3 years, the total value of the account for the money saving account option. Always remember to also add the 0 at the end when talking about money. So now moving on to the second calculation for the bonus saver account. This is simply just a one-off lump sum paid at a slightly higher interest rate at 5.25%, but the calculation will simply be 525. And it's just a one-time lump sum. So plugging that into the calculator, we get the value is 8,946 and 25 pence. So we can clearly see that the money saver account returns a high yield for the investment, but the question's asking how much more money will Tom receive after the 3 years. So what we're looking for is the difference between the money saver account and the bonus saver account, which is simply subtracting the second value from the first, which when you put into a calculator comes out as 7.85 or £7.85, which is our final answer. Looking at question 13 now, we are told the formula below is used to calculate the percentage fuel saving when driving at a slower speed compared to a higher speed. So we're given the formula, we'll just rewrite it out again so we know what's happening with it. So it's 100 times A, which we're told is the original average speed, so or the higher value speed, minus the reduced speed, b, all over the reduced speed, b, and that term is squared. So we're asked to calculate f, the fuel saving percentage, when the speed is reduced from an original value of 60 miles per hour down to 50 miles per hour. So all we have to do for this is plug the numbers into the equation. So A we know is 60 minus 50 over 50 squared. Putting this term into equation, we can rewrite it more simply as first, so that'll be 10 over 50, that all squared, equals 100 times 1 over 5 squared. You can put either this straight into the calculator, or you can simplify it first down to this. Either will come out with the correct answer. So calculating this value on the calculator, this will come out as 4% fuel saving when driving at 50 miles per hour compared to 60 miles per hour. Moving on to the next question, we're told Rahima is concerned about the environment and is looking for a way to become more eco-friendly. She's been researching the use of solar panels for her house and has found some information about the total number of sun hours per month for where she lives for the years 2016 and the year 2017. And the two tables that we get given, first one shows the value for each month for the total number of sun hours, with one missing data point for December 2017. We're also told that the average sun hour per month in 2017, or the mean value, is given by 94.5. What the question's asking is Rahima thinks that the total number of sun hours was higher for December 2017 than in December 2016. So what we're going to have to do is find this missing data point and compare it to see if it's higher or lower than 21 sun hours. So typical mean calculations, what we do is we sum all the values given for that year. So in this instance, we just add up all the values for 2017 divided by the total number of values, which is 12 months of the year, and that would give you the mean value. But in this case, we don't have all the values given in the table. What we are given is the number of values and the mean, and we have to rearrange it to work out the missing value on the numerator here. So what we want to first of all do is add the data points that we do have together. So that would simply be adding 47 plus 61 plus 119, and keep going down this list, adding them all together until we find that value on the calculator as 1103. So what we're going to do as well is just label this value here. I'm going to call it X. You can label it whichever letter you like. You could say D for December, H for hours of sun. I'm just going to label it X, and we're going to rewrite it in this formula here. So this is the total number of hours excluding December, and then we're going to write December value as that. So we're using X, but that's just a representation. X is just a number. So then over the total number of values, which is 12, and this is equal to the mean, which we're told up here is 94.5. So what we want to do now is find this value here, which is just a number, but to find it we need to rearrange it to just make X the subject, or in other words just have X by itself on the left hand side. So to do that, the first step is to multiply both sides by 12. 3 plus X is equal to 94.5 times 12. So essentially what we're doing is multiplying 12 on both sides of the equation, like so, and that cancels out the denominator. Then we work out that this value here is 1134, and plugging it into a calculator, and hence to find X all we need to do is subtract this value from both sides. So we do X is equal to 1134 minus 1103. And that comes to 31 hours of sunshine in December. So looking back at what the question's asking, we're asking, Rahima thinks the total number of sun hours was higher in December 2017 than December 2016, and we've shown that she is correct, as there was 31 hours of sun in December 2017 versus 21 in 2016. Question 15 continues on from the previous question. So here it asks which year had the greatest range of sun hours. So range is simply the maximum value of the set of numbers minus the minimum value. And if you just rewind for 30 seconds or so and take a look at the values given in the table, you'll see that for 2016 the range is equal to the maximum value, which for 2016 is 206. Then subtract the minimum value, which is 21, so the range is 185 for 2016. 2017, the range, it's just simply the maximum value given for 2017, take away the minimum value given. So reading off the table, the previous part of the question, we get 214 minus 6 is equal to 208. So which year had the greatest range in sun hours? Well, that's 2017 had the greatest range. Okay, next, to generate the maximum amount of electricity, a solar panel needs to be south-facing and have a tilt angle of 30 degrees. Typically, you'd see this more commonly written as 30 degrees with the degree symbol as a superscript, and potentially with the degrees Celsius, but this is what the software writes 30 degrees as. We're also told that this will generate a maximum of 1.225 kilowatt hours of electricity for each hour of sunshine. And given that in June there was 108 hours of sunshine altogether. Rahima's roof faces southwest instead of south, and has a tilt angle of 50 degrees C, not 30 degrees C. So, to find out how much electricity her solar panel will produce, she needs to divide the maximum electricity that she could potentially generate under the optimal conditions described here by a factor given in the table below. We're also given the typical price she pays per kilowatt hour of electricity, and what the question's asking from us is to find out how much the electricity that the solar panels produce in June would cost at her standard electricity rate. So to find the factor, all we have to do is read off the table. So from the information given in the question, it's a tilt angle of 50 degrees C and facing southwest. So this is the reduction factor that we'll have to use later on. Now, to find what the maximum possible electricity that could be produced by the solar panel, we're going to do a calculation of 1.225 kilowatt hours times 108. So this calculation would give you the maximum possible energy produced by a solar panel if it was south-facing and at a tilt angle of 30 degrees. Now, since the solar panel hasn't been installed with those factors, it's going to be less efficient and have a reduced electricity output, and that's given by this reduction factor of 1.09. So all we have to do is divide the total maximum potential amount generated by this factor here. And if we put that into a calculator, it comes out as 121.38 kilowatt hours of electricity. Now, the question wasn't asking how much electricity would be produced, but rather how much the electricity would cost if she had to pay for it. So what we want to do is find out how much this amount of electricity would cost at a standard rate given here. So all we have to do is multiply 121.38 kilowatt hours times the standard rate at 0.143, and typing that into a calculator, it turns out that amount of electricity would cost Raheem £17.36. Again, partially a continuation from the previous set of questions. Rahima finds that she can be more environmentally friendly by collecting rainwater from her drain pipe, so that she can use that to water the garden instead of directly from the tap. So Rahima buys a cylindrical container, shown here, that is 80 centimetres in diameter, so that means the diameter is 80 centimetres here, and the total height is 1 metre. We're told that Rahima thinks the container will hold at least 100 gallons, and we have to determine whether she's correct or not. We're given a conversion factor between metres cubed and gallons, and also a value for pi. So first of all, we're given two different units for the measurements of the cylinder, so we should convert that so they're consistent. We could either convert the metres into centimetres, or what's easier is centimetres into metres. So rather, we're going to do another little sketch of a cylinder, something like that. Doesn't have to be that good at all. So that's 1 metres in height, and it's got a diameter, which is straight across, side to side, of 0.8 metres. So to find the volume of a cylinder, we have to use the formula pi r squared h, where h is the height, and pi r squared works out as the area of the base of the cylinder. And it's important to note that it needs to be the radius, not the diameter, which is the information given in the question. So this calculation becomes pi times half of this value, which is 0.4, as diameter is directly across, so that's diameter, and radius is the centre to the edge, so it's just half of this value. So times 0.5 squared times the height, which is just 1. And in this question we're told to use pi to be approximated as 3.14 times 0.41 squared times 1. Inputting that into a calculator, we find that the total volume is 0.5024 metres cubed. Now we have to compare this to 100 gallons, so we're going to have to convert this first of all to gallons, and we get given the conversion factor in the question. So what we just need to do is multiply this term, 24 times 219.97, and typing that into the calculator, it should come out as 110.51 gallons. So referring back to the question, what it was asking is that Rahima thinks the cylindrical water container will hold at least 100 gallons of water. What asked, is she correct? Well, we've shown that she is correct, as at maximum capacity the cylinder will hold 110 gallons of liquid. Now looking at question 18, what we're asked to do is, on the grid below, mark the point for 2. So this is given in standard coordinate notation, where 4 represents the x value and 2 represents the y value. So what we want to do is pick up the mark that they give, go to 0, 0, which is the origin or centre of the grid, then move 4 across. So that's the x value, moving 4 directly across this line. If it was minus 4, you would move this way, but in this case it's positive, so we go plus 4. Then the y value given by the coordinates is 2, so we move up 2. And we just leave the mark there, and that's that question. For question 19, it's asking us to give 144 as a fraction of 240 in its simplest form. So first of all, what we want to do is just write it as a fraction, and this can simply be done by writing 144 over 240. So there we've written as a fraction. Now what we want to do is reduce it to its simplest form. To do this, we just need to take out common factors. So just looking at it briefly, you can see that 12 is a factor of both. So we know 12 times 12 is equal to 144. And 12 times 20 is equal to 240. So we can tell by taking a factor of 12 out from both the numerator and the denominator. An equivalent fraction, that's just a simplified version, will be 12 over 20. And we can go further still. We can take out other factors, so another simple factor to take out would be 2 from each, so take a factor of 2 out from the top and from the bottom. So dividing 12 by 2, 6. Dividing 20 by 2 is 10. And finally, we can reduce it one more time, dividing another factor of 2 out from both the numerator and the denominator. So 6 divided by 2 goes to 3. 10 divided by 2 is 5. So there we have 144 as a fraction of 240 in its simplest form. Next, question 20. Sarah helps organise a Family Fun Day charity event each year. We get told that last year 120 people attended the event, each paying an entry fee of £2.50. It costs £175 to hire the village hall for the event and a further £85 for the prizes. And we're asked to calculate how much profit did Sarah make for the charity. So we're also given this table here where the percentage of money taken is given with a missing value for entry fees, and the money taken during the event, each of the terms is missing. What we know is the percentage of money taken from these should sum to equal 100. So if we take 100% and take away each of these percentages in turn, it should leave the entry fee percentage of money taken. So what we do is 100 minus 15 minus 9 minus 32 minus 19. And that will come out as 25%. So we need to work out what this is monetary value is. So we can do that by multiplying 120 by £2.50 times £2.50, and that comes out as exactly £300. So that's 300. Now the question is asking us for the total amount of profit. So we know profit is the total amount taken minus the total costs. So we could calculate the amount taken by each of the different, so the cake stall, bouncy castle, tombola and wheel of fortune. But we don't need to do that, we just need to recognise that 300 is 25% of the total taken. So 100% of the total taken will just be 300 times 4. So 300 times 4 is 1200. Then we need to subtract the total costs, and we know that's 175 to hire the village hall and further £85 for marked out for prizes. So we do 1200 minus 175 minus further £85. So that'll mean a profit totaling £940 when you do this calculation. Okay, question 21 now. We're told that Sarah bakes 15 identical cakes for the event, and each cake has a radius of 80 millimeters. She wants to decorate each cake with a piece of ribbon around its edge, and also wants to allow an extra 12.5% to allow for overlap. Sarah can only buy ribbon in full meters, with each metre of ribbon costing £4.95. The question is wanting us to find out how much will she spend on ribbons altogether. So first of all, we get given the cost of ribbon per metre,
and the radius in millimetres. So to make life easier, we want to have consistency between the units. So here we're going to convert the radius from millimetres to metres, which will just mean that it's 0.08 of a metre. Now, what we want to find out is the circumference of the cake. A quick sketch to explain why. So, rough sketch of a cake, and she wants to decorate around the edge, so going something like that, right away around with ribbon. So what we want to calculate is from a bird's eye view of the cake, so looking down, so we want to calculate the circumference of the cake, which is given by the formula 2 pi r, where r is the radius. So that calculation is simply 2 times the approximate value of pi given in the question, to 3.14, times the radius given in metres. Typing that all into a calculator, we get the circumference of each identical cake is 0.5024 metres. However, she also wants to allow an extra 12.5% for the ribbon to overlap, so in this case what we're assuming here is they meet perfectly end to end, but in reality they'll overlap a bit in the middle where they meet. So she wants to add 12.5% for that. So to do that we just need to take this value here, 5024 metres, and multiply it by the decimal equivalent of the percentage, which is 1.125, which comes out to be 0.5652 metres per cake. Now we're told, looking back at the question, that she bakes 15 identical cakes, so we're going to want to multiply this term by 15. That's 5, and that comes to a total ribbon length required as 8.478 metres. So she'll need to buy more than 8 metres, so she'll need to buy a total of 9 metres of ribbon altogether. So to find out the total cost, we're going to do 9 times cost per metre, and that comes to a total of 44.55. Now onto the final question of the paper. We're told at the event there will be a Wheel of Fortune game for the children. To win the Wheel of Fortune, you will need to spin the dial and land on one of the 4 green win segments. Given that 15 girls and 15 boys are each having a turn on the game today, we're asked to calculate the probability today that a child who plays is a girl and that she will win a prize. So first of all, working out the probability that the child who plays is going to be a girl. Well, we have 15 boys and 15 girls, so it's simply probability of being a girl is 15 over 30, which can be simplified to half. Then the probability that she wins a prize is given by the probability of landing on one of these win sections versus the whole. So the probability of that is 4, because there's 4 chances of winning, over 1, 2, 3, 4, 5, 6, so a total of 12 different possible segments to land on, which, simplifying this, can be written as a third. Now what the question is looking for is what is the probability that the child who plays is a girl and wins a prize. So and means we need to multiply these two probabilities together, so we get a half multiplied by 1 over 3, which is equal 1/6. So that's our final answer for the probability. Okay, so that's the exam completed now. I'd say if you're going to be sitting this exam yourself, I would definitely practice using the online software. This mock paper is freely accessible on mathsmadeeasy.co.uk. Just getting used to using the software, how to navigate between questions, using the online calculator, plotting points on the grid, will all make the actual day of the exam much less stressful for yourself and enables you to get the best mark possible. Let's also be comfortable with navigating between sections A, section B, and getting familiar with how long each part will take you. If you feel like you need any extra support, any other practice with past papers, or just free online resources, have a look at mathsmadeeasy.co.uk. We've got every exam paper from every exam board that's available online. We've also developed a brand new revision platform, and we have a specialised functional skills course on that platform. This will enable you to access mock papers, questions by topic, and it'll give you instantaneous feedback on which topics you need to work on most. It'll also give you an indication of whether you're likely to pass the exam by sitting true mock exams. And once you get to comfortably above 60% on all the exams you're taking, you're more than likely ready to take the exam. Once you are ready, we are the cheapest online provider of online functional skills maths level 2. And we guarantee to match any price that you find online. Once again, I'd like to thank you for watching, and I hope this has been helpful.